interview. Okay, so what is Sonnet and how the idea came up?
So the idea came up because I have been selected as one of the youngest European leaders in Europe, below 40 years old. And we were 3 years ago in London. And one of the other colleagues is Guillem Anglada. He is the astronomer that discovered Proxima b, which is the closest exoplanet from Earth. So we were debating a lot because I have always been super excited about astrophysics, and seems like he was always super excited about architecture. So we were debating about how we could actually create an opportunity to find areas where we could explore how to develop sustainable cities of world and sustainable settlements. So we started to look for people that were experts in different fields like astrobiology, geology, life support systems, design, astrophysics, and mainly through the academic field in Europe, especially with the relationships that Guillem had, we created Sonnet. And Sonnet, the idea is to create a group that is interested in creating sustainable settlements of world. So we started thinking that obviously Mars and the Moon are the most direct opportunities for us to explore. And we started thinking about Mars because for a self-sufficient city, you need actual local resources. It's not really feasible to create permanent settlements without being self-sufficient. And the Moon is very exciting because it's very near from us, but the amount of resources that it has is indeed not as much as Mars. So we were debating a lot about ideas and how we could find realistic ways to create a settlement. And then Mars Society came up with a competition for creating a city for a self-sufficient settlement on Mars, which was exactly what we were debating for many months and coming up with ideas. So we decided to go for it. And then again, the team was more than 30 multidisciplinary scientists. We headed the design of the architecture, but the beautiful opportunity with NUWA is that it actually was a result of experts from so many fields in the space of science and space engineering and architecture, etc.
Yeah, exactly. And actually, this was the second question, because I was wondering, and I wrote down, to achieve the common goals for Mars colonization, brilliant people across so many different fields, from architecture to astrophysics, from space engineering to chemistry, from astrogeology to design. I know that we're working together. So according to you, how vital is the cross-contamination of the expertise for the future job market?
I mean, it's fundamental because there's so many variables associated with the challenges of creating a settlement on Mars that if we don't work in a multidisciplinary group, it's important for one specific group to be able to provide answers, right? At the same time, from our experience in design and innovation, true creativity comes from that cross-pollination of ideas, right? So when we are talking with groups in the fields of life supports or planetary geology, and they explain some of the ideas that they have, there are a lot of cross-pollination that directly comes to the design board. And that is so important, not only to work on Mars or to solve the harsh environments that extreme location that Mars have, but also to create innovation as a whole. Yeah. So a multidisciplinary approach, we think is so essential. And again, the opportunity that we have here with Sonnet is that we were cross-pollinating ideas with the top experts in fields that are so diverse, and that was one of the reasons why the solution was so realistic and so interesting, we believe.
Exactly, is one of the reasons why I contacted you, since Sonnet is really match the city's goal exactly, because we truly believe in the contamination of the expertise and the sharing different knowledge to came up with new ideas, new innovation. So innovation comes from contamination, and we always say that in the era of disruption, ones who don't collaborate are left behind, you know. It's like the
Totally.
same, the saying go. So go ahead.
And to add to what you are saying, one of the things that we were also very keen of when we were thinking about the designs for a Mars permanent colony is that it gave us the opportunity to think out of the box, and that very connected to innovation that I'm sure you guys talk a lot, right? Like when we are forced to think out of the box, new ideas come up. I usually say to my teams and to some people that ask me that the innovation is not about giving different answers, it's about asking different questions, right? And when we are exposed and when we are forced to ask questions in a different context, like for example, how we can build a self-sufficient city on Mars, we have to reconsider every single thing that we give for granted here on Earth. And through that, we are able to bring ideas that can directly be applied on Earth, because the question was done differently. The answer is different to what questions we usually face here on Earth. And again, there are a lot of exciting ideas that are coming up by the designs that we are creating on Mars that can be directly applied on Earth to improve challenges like climate change and social inequality and material resources. So there are, I mean, we can expand more on that, but there are a lot of exciting solutions that came up over the last almost 2 years of working on creating a feasible and realistic solution on a permanent settlement on Mars.
And that was another question. You already got a point. In what ways can your research and analysis be applied to find solution here on Earth?
There are many things that we can apply. One that is very direct. So on Mars, we have some areas that humans can actually walk, like because they have the right air and the right atmosphere. Other areas are not prepared for humans. It's mainly controlled by robotics, and it's mainly related to food generation and energy generation. Okay, the areas connected to food generation on Mars, we have a little bit less than 100 square meters per person associated with the areas that every person will need. And the reason for that is that we are being extremely efficient with the food technology. Hydroponics is one of the main elements that we are implemented on Mars that is quite recent here on Earth, but it allows for a highly efficient farming. At the same time, we are doing changes on the diet, and animals take a lot of space that will not be realistic on Earth. Not only the amount of energy that they consume and the amount of space that animals will consume on Mars will not be feasible, but also the amount of energy that humans get by eating animals is not that much more than what we get by a diet that is based on vegetables and microalgae and even cellular meat or insects. So in that sense, when we look at the area that I just mentioned, a little bit closer to 100 square meters per person, and we compare with Earth, we start to get really concerned. On Earth, per person, we use 6,000 square meters per person. Wow. On anything related to food generation. That means that if on Earth we are able to use a technology for farming, we are able to reduce the diet so much based on animals, we will have a lot more space that can be used for planting trees, for controlling the erosion that is going on and is deeply affecting to climate change. So this is just one example. There are many examples. We can expand more if you are interested. But again, just by being forced to solve a really harsh situation connected to the life support systems, again, food and how we are going to generate that food and what is the diet base for humans, we realize that on Earth, we're using 6,000 versus what we can do on Mars with 100. Again, the gap is huge, and that gives a lot of room for innovation and changing how we do things here on Earth. Another thing is, for example, the infrastructure, and that's more related to design. Usually here on Earth, when we are looking into creating cities and the designs associated with the urban environment, we usually put the systems that facilitate the life on that city outside, like sewer, water management. All those elements are usually in the back of the experience, right? But on Mars, we were indeed enthusiastic about almost converting those areas as hubs for appreciation, because those are the ones that are indeed securing that you can live on Mars. So the opportunity that we have from the urban environment point of view is to transform the relationship we have with infrastructure that here on Earth we give for granted, but then once we actually understand how important it is for our lifestyle and even our well-being, it can completely relate and change the relationship between humans and infrastructure. More things, the interaction with robotics and artificial intelligence, super complex to live on Mars, to build on Mars. We will need to rely a lot on artificial intelligence and robotics. So one of the things that we are currently exploring, because we are designing similar opportunities on Mars with other projects that are different to NUA, is how that relationship with robotics can actually affect the humans. And for example, I lived in Japan, and in Japan, robots are not just pure tools. They identify robots as beings with a soul. And they actually, robots take care of older people. The integration in society is quite fascinating. And we do envision that moving forward, the relationship between humans and robots will be quite different to how it is now. And again, if done properly, it can transform the social environment, and it can be huge opportunity to improve lifestyle here on Earth as well as on Mars. So materials, for example, and then I just stop because there's so many things that we can talk about, how we can bring some of the learning opportunities that we are getting on Mars and create innovation here on Earth. We had to actually look at solutions that were highly scalable on Mars to build the city. That's why we are going on tunneling, also because it protects the city from radiation and many of the other challenges that we have. We can talk later if you want about that. But then the opportunity that we had is that we have to work with local materials, because it's not feasible to transport things from Earth to Mars, because we only have a window of opportunity of 1 month every 2 years. Therefore, you cannot really scale to a permanent settlement if you rely on materials and resources from Earth. So when we actually started looking at what is available on Mars, we realized that there are a lot, and that we can achieve a lot of things that will be needed for a day-to-day life, but we needed to change the way that we interact with materials. For example, concrete is highly inefficient here on Earth as well. It's very cheap, but it's not sustainable. It brings a lot of damage to the environment, while steel, for example, is much more sustainable. Bamboo is an element that we were considering as well. So there are a lot of opportunities to reconsider some of the materials that we are using on Mars and that we obviously have here on Earth, that can also have an improvement on the some of the challenges that we have here on Earth, especially related to climate change.
Yeah, exactly. Actually, I want to add the question, because of course, when we talk about innovation, even if we are talking about innovation in the outer space, the main goal is always to create a value for an impact, a positive impact on Earth. So that's why I want to link these two different and like opposite things, but at least are not. So, okay, thank you.
Yeah, and connected to what you are saying, Mars is not a plan B. I mean, some people ask me, well, why do we want to go to Mars if we have so many problems on Earth? Obviously, the innovation and the opportunities to learn that we talked about are there. Also, humans are explorers, right, by nature, and that's who we are as a species. But Mars cannot be considered plan B. The analysis that we did with the team of scientists was giving us information. Again, all of this is very preliminary, but doesn't seem like Mars can accommodate more than 100 million people. That means that again, we need to solve the problems that we have on Earth, and why not learn from creating a new settlement on Mars without the mistakes that we have done here on Earth. But it cannot be considered like, okay, we have a lot of problems here, let's go somewhere else and then let's destroy another place, because first, we're not going to fit all of us over there. Second, the environments that are on Mars are way, way harder and way more harsh than the environments that we will have on Earth even after climate change.
And now by this, let's go back to the project for my other question about where SIDI was conceived as a permanent settlement, which is very different than a temporary solution. And humans are going to live there. So when you begin working on the project, what was the core idea of it, and which are the critical points that you face? Because we know about radiation, about the atmospheric pressure, fluctuating thermal conditions that are huge issues. So how did you solve them? And there are the only critical points you face?
There are so many. One of them is that, again, the answer to a question is very different depending on what the question is. And if we have to accommodate people on Mars for a temporal time, it can be 2 years, it can be 4 years. Again, the opportunity to travel back and forth is every 2 years approximately. So if the amount of people that we are going to accommodate on Mars is not a lot, and they can be in small environments, constructions on the surface on Mars could work fairly well. The problem that we have the moment that we start going on bigger buildings is that the pressure that we will have inside of the buildings will be really high, because the atmospheric pressure outside on Mars is almost zero. So the buildings will almost explode like a balloon. When we inflate the balloon, we put a lot of pressure, it will explode. In order to avoid that, we will need a lot of material and a lot of resources to structurally secure the skin and even the structure of the building, right? So we also have many other challenges of building on the surface on Mars, which is radiation. If we are exposed to the sky, even from the solar radiation or gamma radiation, we will develop cancer very, very quickly. So it's extremely dangerous to be exposed to the sky. But again, if we are on a temporal solution, we can always think, well, we can go underground and fine, we won't have light, or we can find some ways to bring light indirectly, but from maybe some type of skylights. But there's not going to be a lot of light, and that is fine for 2 years. It's not ideal, but okay, it can be conceptually feasible. But the moment we start thinking, okay, this is going to be a permanent settlement, truth is that we cannot. Light is fundamental for the well-being of humans. So we started to think, okay, how we can solve all the problems that a large-scale volume of buildings or net of spaces will require. And obviously, we are also segmenting them, creating buffer zones and pressure areas that separate one volume from the next volume to avoid potential mistakes, and that the pressure becomes too big, because the bigger the volume, the more pressure we have. But again, going underground seemed to be a really exciting solution, but we didn't have the opportunity to bring light in an efficient manner. So then what we did was to rotate 90 degrees. The advantage is that on Mars, there are a lot of cliffs. They're very high. We have hundreds of cliffs that are over 1 kilometer high, which is higher than the Grand Canyon in Colorado, right? So in that sense, the opportunity that the canyon offers is that we can generate a tunneling. The tunnels not only provide a great opportunity to create habitats, but if we provide also tunnels that go out on the side of the cliff, as you can see here on my back, then we have a lot of opportunities to bring in direct light. The tunnels, because they're surrounded by rock, absorb very well, or the rock absorbs very well the pressure that we have inside the tunnels. But the thermal differences that you mentioned as well are critical, because Mars is extremely cold planet. Even on the warmer areas, we can have colder days than Antarctica. So the temperature that we will need inside of the human habitats is going to be in the 20 degrees centigrade. But if we are outside in a surface of Mars, we're going to lose a lot of heat. But if we are inside the rock, the advantage is that we have a lot of mass, which once we are able to generate the proper temperature for humans to be comfortable, the amount of energy that we will need to maintain that temperature is substantially lower. And again, that also protects from the micro impact from micrometeorites, and it gives the opportunity to be very dense. That's one of the interesting things of what we are conceptualizing on Mars, that usually cities here on Earth are almost two-dimensional. If you look at the floor plan of a city, you have a grid or whatever layout of the city is, and all you do is just to extrude buildings that might be less or more tall. That is not very dense, and density is important on Mars because the amount of space that we need for the infrastructural connections, that has to be built as well. So if we can build a city in 3 dimensions, that allows that instead of expanding horizontally, we can concentrate everything because we can go in the 3 dimensions, and that saves a huge amount of materials and a huge amount of infrastructure to be able to connect, for example, energy generation with the city, or food generation with the city, or all the different elements that are creating the city itself, right? And that's also one of the advantages that we have with cliffs. Cliffs are very compact, and they usually have very strong performance to the structures. So we are able to create a 3-dimensional net of tunnels that go very deep into the tunnel. They go up to 150-meter depth, but then we can go up and we can go horizontally, right? So that again creates the opportunity to be highly protected, bring light from indirect sources by opening certain tunnels into the walls of the cliff, and at the same time, it allows to be extremely dense while not feeling that is very dense. And that's one aspect that is also very, very important into the conceptualization of the Mars permanent colony.
So the last question about your projects, and then the last 2 questions about you with Alfredo Muñoz. So what will day-to-day life on Mars be like?
What the daily life will be like on Mars?
Life, yeah, the day-to-day life on Mars be like
so it will be quite different from Earth, especially because society and the way that we envision life will be quite different. First, because of the space. Again, space is very expensive to build and is very expensive to maintain. So what we are envisioning, and this is connected to more additional work that we are doing on Mars settlements, is to have an apartment that is individual for 25 square meters. And the opportunity that we have with that is that you still feel like you have some privacy. It's not a lot. Again, 25 square meters per person is not huge. But then we have a lot of common areas that are shared by the community. And that connects to how we envision the society on Mars. We think that the environment is so harsh that we need to rely on each other to actually survive. And the sense of community and the sense of belonging is going to be critical on Mars. In that sense, the way that we are creating the urban context and the architecture is to emphasize and encourage that sense of community. So living on Mars on a day-to-day basis will be similar to how we live in a dorm, or how a co-living environment is, that you have your private space instead of 5 square meters or 10 square meters. Like in a dorm, you will have 25 square meters, but then a lot of the common areas and activities happen through a social context. And that's one thing that will be important. Then again, the relationship with robotics is going to be quite critical. We envision that the interactions that will happen between humans will be merging with robotics and artificial intelligence. There will have to be a lot of work. The amount of energy that we estimated we will need per person on Mars is 10 times the amount of energy that a person on Earth generates. That's a lot. That means that we need to generate that energy somehow. We cannot work 10 times more because there is no hours in the day, and indeed Mars has very similar days as here on Earth. So we actually need to have a lot of the robotics and artificial intelligence generating that resources through energy, food, etc., that we will need. But we need to manage those resources. We also envision opportunities for mining, and there's going to be trade between Earth and Mars. Communication is quite possible. Usually takes 15 to 20 minutes to communicate between Mars and Earth, and there will be trade, as I was explaining you. We have a window of opportunity to travel back and forth every 2 years. So the work activities mainly connected to science and robotics, we envision are going to be of utmost importance, but also the personal growth. We think that, again, living in such a different environment will allow us as a species to evolve and to look at our environment and our context in a much more connected way. We think that living on Mars is going to force us to see our surroundings as part of us and not so much detached. So we envision there's going to be a lot of opportunities for spiritual growth and for the development of arts, in the sense that, again, that strong need to rely on your environment and in your context on the social aspects will affect a lot the way that the Martians will experience life, right? So, and then there will be opportunities to entertain and to have fun. Again, we are envisioning a colony on Mars, like a complete city or a complete settlement, where we will do all the things that we are used to do on Earth, but quite different context, and everything kind of surrounded by an environment that is very communal.
Yeah, wow, amazing. Okay, so let's talk to you. Last two questions.
Okay.
Inside the project, how and when you realized to be committed and interested in space exploration, and how did you match with architecture?
So I was always interested in astrophysics. Indeed, when I was studying high school, I was debating between going for astrophysics or architecture. So I was very, very interested always in space, and I have always been kind of training myself in anything that was related to the space. But then when I started ABIBOO Studio, we started to do a lot of large scale projects in areas in India that were quite remote, which are connected to extreme environments. And we had to do, again, self-sufficient environments, because some of the areas didn't have utilities, didn't have even access to the roads. So we started to become very familiar with building innovative architecture in extreme environments. That connects somehow with space architecture, because obviously building on Earth in harsh locations is much easier than building on Mars or on the Moon, but there are a lot of commonalities, right? And then I became a part of the technical committee for space architecture from the American Institute of Aeronautics and Astronautics. So I started to become quite connected to the community mainly in the US, that is deeply exploring how we can use architecture as a way to bring innovation into the space industry. So the opportunities that we are working with creating a permanent settlement on Mars go very connected to my personal interest, to the expertise that in ABIBOO Studio we have been having for 10 years with extreme environments and self-sufficient settlements, and with the opportunity that we had with Sonet to work in a multidisciplinary group, and the opportunity that I had to be part of the technical committee of the space architecture in the American Institute of Aeronautics and Astronautics. So kind of bringing again a lot of connections from fields that apparently are not that connected to architecture, but at the end, once you put them all together, it gives the room to, again, question things differently and therefore give answers that are quite different.
Quite fun. Okay, so the last question, and I don't want to steal you time anymore. What advice would you give to those aspiring to become space architect, and what are the first steps to take?
So I think the first one would be to get close to people that are very connected to science, as many different fields as possible. Again, for us, it was very important to be able to brainstorm with people in life support systems, in astrobiology, in aeronautics, and that was very important. Secondly, to read every single thing you can about space architecture and the conditions that we will have to face, because again, they are very different than Earth. Sometimes we give for granted things on Earth that definitely are not that obvious on the space. And third, to just throw yourself out there and start proposing ideas, because we learn a lot by doing, right? So in that sense, you can never be the biggest expert of all the experts if you don't start making mistakes and getting corrections from the experts. So in that sense, if you are able just to generate ideas, put them out there, try to join groups, like Space Architecture Group, for example, is a fascinating group. Is organized by headquarters in London, but we are all over the world. And that can give a great platform to share ideas and learn from other colleagues, and also to just don't be shy about making mistakes.
Thank you really for your time.
Thanks to you for being interested in our work. I will send you soon some information on new things we are working on Mars. I think you will be quite excited, because it's a immersive experience on how living on Mars will be through VR and technology, building a metaverse on Mars, and it's going live very soon. So we'll keep you updated on that.
Yeah, keep me updated about it.
Great, Paola. Thank you so much. It has been great pleasure. Hopefully we'll meet in person soon.
Of course. Okay, yeah. we will one day, of course. But
very good.
We can set up another call just to make like more our collaboration grow and bigger than this one. Okay, we have just started with the School of Disruption. I really want to. Do you join our School of Disruption as endorsement? So we will have, we are creating a huge community actually.
That's great.
For the students, for professionals. So we are moving the right step. I'm really satisfied. And doing with passion and determination, it's fine. Nice,
Paola. Thank you so much.